Hello, everybody. We will start just in a few moments from now. Thank you. Okay, hello, everybody. Welcome to the fifth part in this webinar series from Good to Great about multi-input processors. And today we actually were thinking to show you many features that are related only to the multi-channel machines, like axis patterns, superimposition, how to correctly set up the proper output code settings, and how to correctly output the wait marks that are very critical, for all multi-channel machines. With that said, before we go into those subjects, I would just like to remind you that all of these webinars have been recorded, and you can find it in the solicam.com webpage. And for there are two places where you can find it for all the resellers and stuff. You can find it in the reseller area, but of course you can go to the videos. You can jump on the weekly webinars, latest webinars, and then basically you will see here part 4, part 3. You can download the video and the presentation. Now the small difference in comparing to the last uploads is that you can click on any of these videos and try to not watch it on the website, as there's a great beneficial if you just watch it on your YouTube. If you jump into YouTube, basically at the very bottom you will see actually the description, and basically you can just click on any of these links and it will go to the related topic. But besides of that, you can actually see in the player itself, there will be the bar highlighted over here, so you can easily jump to any of those subjects that is mentioning also in the description. Yeah. With that said, as I said in the early beginning, today, let me just exit from this. Today we're going to talk about mostly about the superimposition, even though that many of the other stuff like axis patterns, weight marks are really related to this topic. What I have open here is the channel synchronization reference guide, or the documentation. If none of you, if some of you didn't saw this documentation, it will be in the description of YouTube. Okay, so if you go there, you'll find the description. So I'm really recommending you to read this document before watching the webinar or the video again. Yes, but I'll try also to repeat many things that are actually located also in this documentation. Okay, I will not go into depth how to control the channel synchronization, or let's say what are the basics about the channel synchronization, but I will talk mostly about the more advanced stuff, like in this case and on this webinar is the superimposition. Probably you heard many times about the superimposition. For some of you who never heard about it, I'll try to explain it what it is. In general, SolidCam supports 3 different types of superimposition. That is simultaneous, constant, or we also call it locked. I will explain also why we also call it locked. And we have also inductional. Okay. The most, how should I say, beneficials are the simultaneous and constant, for which I will be in focus the most. But of course, I will also show you what the inductional actually means as well. Now, this is the feature that not every multi-channel machine has. Okay, so first of all, in this webinar, I will explain this feature, by my opinion, on the most easiest kinematic that I found on the machine on the market. And that is the machine that you can see here on the left. I will jump in the software as well. And also on the right side, we can see also the example of the constant or locked superimposition, where once the sub-spindle clamped the part on the main, if you want to move the Z1 axis on one channel, the Z2 will basically follow this. Basically, superimposition is, in other words, the dynamic work offset. So basically, machine should know on another channel, and it should dynamically change the work offset based on the sum of the axes that it's set up as a superimposition axis. Yeah, so let's just jump into software. And over here, I prepare a pretty silly part here. And the machine that we have here is, I'll just go jump into preview. It's the same machine that you've seen in the documentation. It basically has the main spindle, which only has the Z-axis, and the sub spindle. The sub spindle has X2, which can go to up to 129 in X2, and also Z2. Now this all is actually channel 2, and also we have the upper turret revolver. Upper turret revolver is classically X1, Y, and Z axis. Now with that said, naturally you will ask me, how actually this machine can work with 2 X-axis or 2 Z-axis. So the answer is simple, basically the superimposition. Okay, I will go into details also later. Now, for me, the most important is that you see this kinematic over here. And in this moment, the VMID is defined really minimal. So I just defined the axis, the revolver with 8 stations here. We have the main spindle, we have the sub spindle. We have minimal 1 submachines. We don't have any channels, any axis patterns. So this is like where you will basically stop during the definition of this machine. I didn't want to do this from the scratch in order to save the time. Now, before we just jump into the definition of submachines, I would like to show you what I want to replicate in this video and how to support that in post-processor. So I'll just jump into one video here. This is exactly the same machine which I was inspired to show this feature, as it is, I would say, the most simplest kinematic, but this machine gave such an advanced feature, which is very nice and representative for explaining those features. Basically, I will try to run it. I'm not sure how fluent that would be through the GoToMeeting, but hope you will get it. So basically, over here we have the stopper, which actually extends here the bar. And basically what we have in this situation, I stopped the video, is we have one station where we basically have the tool that is on the main spindle, on the spindle 1, and we have another that is on the spindle 2. Those, in this moment, you can, or you don't have to, you can run it in superimposition mode. In this video, in this situation, it is in superimposition mode. And what is very important for this machine to say is that sub spindle cannot go beyond X2 axis. If you have any questions, I didn't say this in the beginning, but you can you may feel free. You have the chat area, so I will summarize all the questions at the end of this webinar. Now, as it cannot go beyond, it can go only lower than that. Another tool, it's a little bit more extended than the first one, as you can see over here. This is very necessary on this machine. Now, what is happening once the machine goes into superimposition mode? Usually that's some kind of M or Gcode, okay? So it's just a macro that will allow such a thing. Basically, the offset that is on the part over here, changing the X and Z, usually on the machine doesn't change the work offset. So basically, if you change the part position from this position to this position over here, on the machine, the G55, in this case, let's say, it will still be over here. It will not dynamically update. So the superimposition, in other words, I also mentioned this earlier, it's like dynamic work offset. So let me just run the video. And basically what you will able to see that 2 parts are machine together, where the Z1 axis is the main axis and Z2 and X2 is following the revolver. As you can see, even in the rapids, the part actually follows the tooltip all the time. So in this webinar, I'll just try to demonstrate that our end goal would be, to run this mode in SolidCam, and also show you, how to implement that inside the post-processor. All right, let's go back to our VMID. So let's get started with. First of all, we already will start with the definition of the submachine. As a default, always you need to have minimum 1 submachine. So basically, you cannot remove the 1 submachine. Okay, so you always need to have 1 submachine. In this case, it's my revolver and my table, which is in this case spindle 1, and they are highlighted, as you can see. So these 2 works together. For this, I will just mention it's spindle 1, and maybe I can also mention the axis that I will use, but I'll do that later on. So basically, I'll go to the axis order, and in this case, my z-axis, z kinematic axis, will be use the z1. Then my y-axis will be y, and x will be x. So these are completely fine. To use in the milling, we all like to use it simultaneously. While for a C1 and Y1, we don't want to use it in turning. In the turning, just the Y-axis is used in dexial, while the C it's not used at all. So this is how you should set up it, the pretty much standard revolver and main spindle submachine. So in this case, so we will just say it's spindle 1 revolver. Okay, so let me add another submachine. Now this submachine would be, upper turret subspindle, and most likely you can guess what it would be. So I'll just maybe copy this submachine, just paste it over here, and I'll call, this will be the spindle 2. Then I'll say spindle 2 and the revolver. Done. It is in operation type. Make sure that it's milling and turning itself. My coordinate system for this submachine, I will rotate it around the X. So basically, if I turn off this on my subspindle, the orientation of my output is just 100 degrees, around the X. And my axis order, as you can see here, I need to choose now. Basically, the SolidCam VMID will read all the axes on each device that are selected. In this case, it will list the Z1, Y1, X1, Z2, X2, and C2. Now the question is, which one of those X and Z axes are kinematic and which one are not kinematic? It means, in other words, when you type the X or Z in that channel, which axes are actually moving? Now this is the interesting question. When I get this machine to work on the post-processor, my question was, okay, which one is the master one? Does the sub spindle needs to go, to align position with the main spindle and then work with upper turret, or the upper turret must go a little bit low in lower position, and then my sub spindle should work on that tool? At the end, I realized actually the machine can support both of these, but also it can support with the superimposition. So I'll try to define the minimum of the things. So the first one will be SP2 and a revolver, where I would say maybe I would like to do it where my X2 and Z2 are the main one. As you can see, by default, so I can choose the right one. So X2 and Z2 are my main, and I have my Y-axis that is on the upper turret, which is simultaneous. My C2 axis in the turning, it's not used. Okay, now if I define my VMID in this way, basically I will support pretty much standard mill turn with one turret and main and sub spindle. Okay, either though in this situation, if your sub spindle doesn't have the X2 and Z2 axis, in this case I would do in this way. Okay, so let me go back to this. So it will be Z, this will be X. This will use the indexial, X2 it's simultaneous, and in milling it's simultaneous. All right. Now, how to define actually the superimposition? First of all, I would like to show you one thing. I will leave it this as it is. And what you can see here, if I go to the axis order, my Z-axis here, I can click and I can choose only the Z-axis here. Of course, beside of the X and Y, I can select only the Z-axis. As default, you cannot say that in SolidCam, you cannot say that this axis is superimposition only. Okay, so first of all, the minimum that you need to have is that you have one submachine that has kinematic as Z-axis. Now, if you remember that I take this and I make a copy of the same one with the same revolver, where it is the same revolver, in that case, SolidCam, what SolidCam allows me is that to select that Z1 axis as a combined axis. Otherwise, if you didn't create at least more than one submachine with the same turret, in that case, you will not have this option of combined axis. Now, what the combined axis actually is. So looking at this, what I mentioned you earlier, I want my table to be the kinematic axis. So this is my main one. I completely forgot in this one, and for the main, I don't want to mess with this. And if I'm looking only at this side, I can say that this is well enough. But if you want to run something as superimposition, then you need to consider which of the axes are superimposed axes. And in this case, it's Z1 and X1 axis. They are the master that I would like to be guided, let's say like this, okay? So if you want to do something like this, you just click on the combined axis here. As you can see, for the milling and turning, it will be automatically set to superimposition. And I will do that exactly the same for the X axis. And then, as you can see, they are completely selected as well. Okay, but this is still not over. How we should know, how we should turn on the superimposition to be on or not? Yes, because we should be able to choose when I want to run it or not. In such a case, we need to define something that is called axis patterns. But before going to axis patterns, we need to define channels. As you can see, this machine, it's two-channel machine, as it has two X and one Y and two Z axes. Because of that, it has two channels. And then I'll just do a right-click. Also pay attention, you have auto-generate channels by turrets. Many mill-turn machines, I would say conventional mill-turn machines, you can use this option to auto-generate the channels by the turrets, by the number of the turrets. In this case, if you have two turrets, in that case, this option would be perfect, as everything will be automatically done. But you need to be careful. In this case, my channel is not based by the turret, it's based by the table, as everything what is done on the main spindle, it's channel 1, and everything what is done on the sub spindle, it's channel 2. All right, so what I'm going to do, I will just add a channel. And as you can see, adding a channel will basically automatically insert the axis pattern. I still don't go to the axis pattern yet. Okay, we'll go to that later. And my channel will be, the mark with this. You can name it as ever you want. This name itself will go to the general interface of the channel synchronization. So just remember this symbol, and you will see where this label it is actually located. Then I will add another channel, and this will be, of course, the channel 2. They have their own IDs, very important for the output later on. And now the question appears, like, okay, what is the maximum number of the linear axes that can be manipulated in the first channel? So I would say X1, Y1, Z1, and the C1. Yes. So the number of the linear axis is 3, and the rotary axis it's 1. Now, what this actually means, it's not only as a question, because this could be probably automatically generated from the SolidCam, but it also influenced to the channel synchronization. I will show you also where it is later on once we enter to the channel synchronization. I'll go to the channel 2, and in this case, in channel 2, I can also manipulate with, I would say 3, but plus Z1 and X1 as a superimposition axis. And 1 rotary axis. In this case, I think the 3 linear as a kinematic and 1 as a rotary would be enough. If it's necessary, we will increase it. We'll see later on. Okay. Now the thing that I forgot here is that I need to involve the submachines. I need to say exactly which submachine is actually for which channel. To do that in SolidCam, in the VMID, what you have to do is to do a right click just below this last parameter. Just do a right click and add a submachine. And once you click on the submachine, you will be able to pick up that submachine from the list. So I'll just click on spindle 1 revolver. And for channel 2, I'll just add the submachine, and I'll just say spindle 2 revolver. Good. I'll just save this time. And now, if something is not correct, the VMID will say, okay, but the Z1 is not distributed to any channel. Okay, so what is all about? Even if we say correctly, that I want my axis I want my axis to be used in particular submachines, we still didn't allow that in axis patterns. So what is the axis pattern anyway? The axis pattern is nothing but, once you go to the controller, switching between the channels on the controller itself, you will be able to see the axes that are active there. Basically, with that said, the same thing you need to do over here. Now, why we use the axis pattern in SolidCam? There are two reasons for that. The first reason is to activate or deactivate the superimposition mode, okay? And the one that I mentioned here earlier, I'm talking all the time about simultaneous, okay? The simultaneous one can be activated or deactivated only by the axis pattern. The constant or the locked one can be activated or deactivated by the MCO itself. Okay, and the second thing why we are using the axis patterns is actually axis sharing. Not every military machine requires the axis sharing, okay? But I'll give you one example that I actually describe in this documentation. It's just a few pictures over here below. And this is a very nice example on the Swiss time machine. And very quickly, you can see this axis here and this axis here. Pretty similar kinematic with this Miano that I'm just presenting to you. We have here the X1, Y1, and Y1 axis on the first channel. And here we have the second channel where we use only the X2 and Z2 axis. Now, the machine has an option to add more turrets here that basically allow you to put more tools to work on the subspindle. But hey, how you can actually use those tools if they are located on the first channel? So you are located in a completely wrong tool, wrong axis. In this case, machine builders make something that they call axis sharing feature. It's basically one M code or one G code. It depends from manufacturer to the manufacturer, where in both sync labels, you print out these codes in both the channel, and then the axis will be shared. Or as you can see here, I just gave the example like X1, Y1, Z1, C1, X2, Z2, C2, but it's also possible to make like a Z1, C2, a C1, sorry, and then X1, Y1, C2, and C2, yes, Z2 and C2, sorry. Basically, we switch the axis between the channels. And this axis switching is only possible within the weight label, yes. So in both channels, you need to print out these values, yes, or these codes. So with that said, let's see how we can set up our Miano. Okay, so for the first channel, we can use something that we see here, and can it be used on the first channel? Yes, it can. So I can say normal and default. By the way, as you can see now, something is wrong here. I cannot switch here. Something is happening. Let me save. Not possible. Let me go over here. Maybe this is fine. This is also very, very fine. Channel 1, channel 2. Let me try to auto-generate the axis pattern. This one will be, yeah, now it works. Okay. So basically, if you do a right click over here on the axis pattern, you can auto-generate the axis pattern. And if you auto-generate it, this would be a default. So the Z1, Y1, X1, and C1 will be a normal. I would just like to click on this option and to give you a short brief what are the options. Now, I will not talk about this one, but let's say, for example, the Y-axis. The forbidden means this axis cannot be used on channel 1. Normal means it may be used, but it's not a default, okay? I will also explain what is the default. So basically, once you start a machine, what is a default? And then we have the normal and default. Now, what you can note here is that we do have for the axis that we say as a combined, we do have a more option, like a superimposition default. We have the superimposition and normal, and we have superimposition and normal default. Now, pay attention, if I go to the axis order and turn off the combined axis to be like non-kinematic, you'll fastly see that I don't have this option anymore. So you must be careful. If you define once this to be combined axis, and here you define this as a superimposition and normal, then make sure that you don't change the axis order. If you do change it, please make sure that you also redefine the axis patterns itself. Okay, now as you can see, this is a default. On channel 2, it is used as a normal because yes, sometimes it can be used as a normal, and this is completely fine. Now, if I click on the axis pattern, a few things are very interesting. We have here the name, we have here the GPP name. The name itself, I'll just call it, I don't know, this time I'll just use like something that I really like, the name itself that will be popped up in the channel synchronization, and then this will be like this. So everybody would understand that this is the channel 1 and this is the channel 2. And the GPP name is the name that you actually can find, the default, that you can find when you're running actually the get function. Okay, so if you go for everybody who didn't follow maybe some of the previous webinars, basically if you go to GPP tool commands, in the get function you can get actually the axis pattern. Where it is? Here it is, getting the axis pattern name. Basically you can use this get function in order to get this actually value for the axis pattern. I'll talk more about this for sure. Okay, so if we now save, you'll see we don't have any more error message. So we can say that now this machine, we can use actually this machine, okay? I'll just save and exit. And now I'll try to unsuppress those operations. What you can note that once you change the axis pattern or anything in the channel synchronization, anything in channel, sorry, you can see that SolidCam will actually close the CAM part. Now, closing the CAM part means that something has to be recalculated again. In that case, you just need to reopen it, okay? This is pretty normal behavior, okay? In this case, you can see the channel synchronization requires some change, okay? So no matter when you change anything here, the CAM part will basically close. Okay, so I'll just do a right click and unsuppress this operations. All right, and I would say that all those are defined in spindle 1 revolver, and my part transfer and everything that is after the part transfer, I will just move the submachine to spindle 2 revolver. Okay, let me recalculate it. So what I do have here, it's basically 2 operations, 2 on main spindle and 2 on the sub spindle. Very silly one, just the center drilling over here. On the sub spindle, we have equally the same operation. And then I have like 2 turning jobs over here that are like pretty much similar. Geometry doesn't have to be similar, okay? You can do whatever you want, yes. Now let's see where my let's say where my tool it is located when I'm running this on the main spindle stuff. Yeah, so I'll just go to the machine preview, and we are over here. Okay, all good, all nice. I do have some. I have one question here. Sorry about this. And okay, I'll come back to the questions at the end of the webinar, as I mentioned earlier. Okay, so here's the turning job over here, nothing so special. And over here, we'll have a part transfer. Just before the part transfer, I'd just like to make my upper turret revolver to move into a home reference. Let's see. Yeah, and still this is pretty, let's say, pretty far. We'll probably hit this, but I'll just leave it as it is. We'll have a part transfer here, then working with the X2 position. This is interesting. MCO, basically nothing so special. We'll just move the part to be aligned with the sub spindle. Sorry, with the main spindle. So we actually approach here and make a proper proper movements, yes, because otherwise, if the part is located down, where is the home reference, the turret cannot reach this part over here. Okay, so let me just very quickly go to the channel synchronization. It is on another screen, so let me just move it over here. Okay, now this is the channel synchronization, and I will now remove all the labels, and I'll just go with 1, 2, 3. And what I like to do, as you can see, this one is a little bit bigger, this one is a little bit smaller, and just what I like to do is click on the very first icon and then on the very last icon, and then this will be a default view by yourself. Yeah. Okay, so the few things, the labels. So the channel 1 over here, this is the label that we actually define in VMID. Then we have the label 2, or sorry, not the label, the channel 2, and the text label that it's from the VMID. We have the weight marks here, 10, 20, 30. We have everything what is done on the sub spindle. We have everything what is done on the main spindle. We can actually simulate and generate the Gcode for this machine. Now, the things regarding to the 3 linear axis and one rotary axis that I mentioned in the channel, it is related to these columns here. So we have here 3 for the linear and 1 for the rotary. As you can see, this is the maximum capacity of axis load per each channel. As you can see, I add the same thing also on the second channel, even though that one axis is not here as a default, but it can be used, right? So this is probably you remember as well. Now next to it, we have a very small column here as well, or row, however you want to mention. Also on the both spindles, both channel sides. And this is related to the icon that it's like a drive unit or access unit sharing. It will be displayed over here. Okay, you can maybe watch some of the previous webinars about this. Also, you can find it if you type the SoyCam multi-channel machine, basic and advanced. One will be also available on YouTube. And then I actually talked about these icons over here. All right, now let me just go to the machine simulation. Okay, I will just go to the top view. Here we are. So basically, we have nothing but the setup. We have the center drilling. We'll change the tool. Then we will have the OD turning. Then we'll stop the part, go to the reference, and now just a simple part transfer. So alignments with the main spindle, pick up the part, go there, and then center drilling. Okay, this is now interesting because what we said there is that X2 and the Z2 is my kinematic axis. So it means that X2 and Z2 will be moved towards the tooltip. In this case, I should probably use or take the turret to some safety position down below, and then actually I will have this working completely fine. Otherwise, if I leave it as it is without the axis pattern, you will probably see that my axis limit overflow here on X2, it's done. So I can click over here and it's there, yes? So guys, how we can actually activate the superimposition and run this together. So let's go to the VMID again. Again, going to the axis patterns. So if we do have only one axis pattern, and if you go to the channel synchronization, switching the axis patterns can be done on the label level. Okay, if you do a right click over here, you see nothing. You see no axis patterns. Generally, the axis pattern, all axis patterns will be listed here, but only if you have more than one axis pattern. Okay, in this case we have only one, so the default for each label would be the same. Now let's go and create another one, and I'll just copy this one and just paste it over here. And this one will be my X1 will be superimposition. X1 also will be superimposition, and X2 and Z2 will be on the second channel. So this would be my, let's say, superimposition axis pattern. Now, of course, you can also type any like a G750 or anything that is, like I said, something that can be very nice for you to find in the post, or so you can do something like this. It's really up to you. Yes. Now, what is the key here? The key is the axis distribution here. Instead of Z1 of the normal and default, what you should do, you should change to superimposition. Now, my advice is if you say to superimposition, it means in this case, only the superimposition as a default will be used. But this axis cannot be used as a normal kinematic axis. So which means normal, it means like a kinematic axis, meaning that only if you change the Z1 and Y1 somehow will actually have an effect on another one. And in this case, in most, I would say in 99% of the cases that I had, I only use the superimposition and normal as a default. Okay, as this was working for me very well. And also for the X1, a superimposition and normal default. All right, I will just save it. And as you remember, once you change anything in the axis patterns and you save it, compiler will basically close. So the only thing what you have to do is just go and reopen the part. Okay, so as you can see, nothing changed. But this time in the channel synchronization, we are able to switch between the axis patterns. Okay, now switching the axis patterns will basically change the labels that are located over here. So if I do a right click and change it over here, it will allow you to use the axes that are on this axis pattern defined. Okay, now nothing has been changed. Why? Because we said, okay, on the first channel, Z1 can be used as a normal, but also as a superimposed. But we don't have any operations here done, so I don't have to make this axis superimposed. So how to do that? How to activate the superimposition? The superimposition can be activated only if you're using, the advanced feature when you have the release stock, doing the add a new workpiece, when you simultaneously synchronize 2 or more jobs. Okay, as you've seen in this video, 2 jobs needs to be defined if you want to use it in superimposition. Okay, in such a case, I'll just take the very first job at the end of the after the part transfer, and I'll do a right click and add a new workpiece. So basically everything what was at the bottom will go up, and we will get basically the 2 parts. To see that, basically you can click on this filter, color operation by the workpiece, and everything what is yellow is one part, and what is another color, whatever color this is, you can also change the colors in the VMID settings. Basically it is another part. All right, now what I'm going to do, I'll just delete the synchronization label, and what I want to synchronize is these 2 jobs, because this is a center drillings, and I would like to take this and to synchronize those 2. Make sure that you have only 1 job there, so I will create new wait mark over here, and I'll also split those 2 as well. Now, as you can see here, now I can simulate it and generate the Gcode, but I would like to talk more about the superimposition. In this superimposition mode, we actually get this S symbol next to the axis, which is actually now superimposed. That is the X1 and Z1. And if I do a right click, you can see that SolidCam automatically selected those axis patterns. So I'm not even able to select the first one. Okay. Now, what is very interesting that here on the right side, you can see that Y-axis, it's also used on the first channel, but also it is used on the second channel, where it is displayed as locked. Now, in the same, I would say in the same, let me go to this. In the same axis pattern, let's say in the same example, we can have both situations. Either 2 axes are completely superimposed, but also the Y-axis, which in this case is here not displayed, it is also called constant or locked, which means if I move my Y-axis on one channel, on the first channel, let's say, also the same value will also reflect to the second channel. Okay, so it will follow. Yes, I'll give you also another example. How to activate this lock feature as well. Okay, so let's see now. I'll just go to the simulation and go to the machine simulation. Of course, I forgot to turn off this working X2 position, but I'll suppress this operation later as we don't need it now in this moment. So I'll just go here, go to the top, maybe turn off the channel synchronization, maybe turn off this as well. Okay, go to the setup. Now, if you see now, I click on the setup. Now we see the both parts because we use the add a new workpiece. And now we do a center drilling on the both spindles. Yeah, so I'll just minimize this, go to the length mode. Hopefully you can see everything, guys. So basically the work offset or dynamic work offset, it's loaded on both, on the second spindle. We are going now up and basically changing the tool. I want to simulate that, and then the simple turning is performed. We have the part transfer here. It was obvious that will make a crash. It's completely fine for now. So guys, this is the simplest example that I could found regarding to how to define actually the superimposition. Let me show you actually how to make a constant or locked superimposition as well. Following the example here and the constant one, it is related to also, it is very frequently used on switch type machines, especially in the part transfer. When you want to perform the part cutoff, in the case when the subspindle lock the part on the main spindle, those two axes, Z2 and Z1, must be in superimposition mode, or in SolCam it is defined like a constant or locked superimposition, basically because Z1 will actually follow the Z2 by the constant multiplier. Okay, and let me show you how to do that. So this superimposition cannot be defined in axis, how should I say, in axis pattern in the channel synchronization, but by the MCO. So how to do that? Let me give you a small example. So I will take the turning job here, and for some reasons I would like to do this. Let me go here. I have here the subspindle. So let me take an example, and I will say, okay, everything what my Z-axis is doing, I would like my Z2 to follow, wherever that is located. Okay. So how to do that? For this, you need to have an option enabled in VMID. So I'll go to the VMID, and I'll go to my particular revolver, as I would like this revolver to be my control device for this feature. I'll just go to my options, and here we do have like an axis synchronization. So the axis synchronization, it's basically a locked superimposition, okay, option. So I'll just go on and off. So I'll just save and exit. And now before this turning job, I would like to add another MCO operation. And then I'll take my revolver, and then I will see here, now you have an option for the axis synchronization. If you didn't allow that feature in VMID, the axis synchronization VMID will not be allowed. So I'll check on this, and then I can see, okay, my status it's on, my master axis it's Z, my slave axis it's Z2. It can be any other, sorry, it can be any other that it's with the same vector, and then we have multiplier. Okay, what is the multiplier? Multiplier basically defines is it in the same direction, or maybe it can be in opposite direction. It can be multiplied by 2 times or any other factor. Usually that is like 1 or -1. I'll save it, and I'll leave now the job. As you can see now, the channel synchronization asks us to make to check and to make some change. And this time I'll just remove everything what I have done, and I will go 1, 2, 3. And what you can note now is that I have here my channel synchronization here, and oh, one thing, let me go back here. Okay, good. And I'll save this I'll export and I'll call this superimposition. I would like to load it later. It's very important. And yeah, let me go delete all 1, 2, 3. And now this MCO, where we have the access synchronization, have this superimposition here, which we'll have here as well. So let me simulate it right now. All right. So let me go just jump in this MCO. And then let me go to the top view. And then let's go to this job. So whatever this spindle is, he will follow the Z1 axis. So let me run it. So the Z is following, but not the X, okay? So I hope you get more information of how you actually can define this feature in SolidCam. Of course, there are many more difficult machines which has this option, okay? And I hope that this webinar and this video actually give you more information how actually you can use this feature. Now, I will go back with the channel synchronization, but let me just remove this job. And channel synchronization, I'll try to load the superimposition. Let's see. Yeah, everything works fine. Now, I would like to just jump into how to define the labels in SolidCam, and basically how to define the superimposition and what is actually the most important procedure regarding to the channel synchronization. So I'll just save and exit. And for the first time in this webinar, I'll just jump into a post. All right. The most important, let me just zoom in for you guys here. But the most important procedure in channel synchronization is actually the sync process. The sync process actually is defined in both channels and basically represents the sync label. And this is the way how two channels actually communicate between each other. Now, I will not go into details of channel synchronization in the code, as this is, I assume that you understand those things. What I would like to go is through this sync process, all variables that are located in this procedure itself. So let me go to this, and I will just go to the trace. And this time I'll not go with the trace 5, but I will go with the trace 1. Pay attention that sync process is very important procedure. And even though if you go with a trace 1, will basically create as it is a trace 5. It will go all the information about this. Yes. So let's go with all informations what are located over here. So first of all is the sync label. The sync label is the very first one, and it basically represents the label. So if you go to the channel synchronization, the number that is located over here is basically the sync label. Yes. The last sync means if it's the last synchronization label, and if I go and jump to the end, you'll see the last sync, it's actually 1. Now we have here also label numbering style, it's 0 or 1. It means if we use also advanced feature, basically if you go to the settings, you can also use a default, or you can use alternative. If you use alternative labels, you can allow that in the VMID. Basically, this value will be then 1. Now we have the channel ID, a very important variable, basically which channel it is at the moment. We have also the channel name, or let's say label text, basically as we define in VMID. We have involved channels, and as you can see, involved channels is like _1, _2. What that actually means. In the 2-channel system, it will be always 1, 2. Always. This is very important variable for 3, 4-channel machines. Basically, it indicates which labels are involved in the channel. Okay. In this case, both channels have this sync mark. But let me give you example from the from the PDF, if I just roll up here, so this channel synchronization this machine has 4 channels. And in this case, you can see that some of the channels are not involved. For example, the label 2, it's only involved in channel 1, channel 2, while in channel 3 and 4, we don't have any. In this case, the variable will be 1, 2, and not 1, 2, 3, and 4. Okay, so this is how this involved channel actually works out. Then we have the device ID number. Device number is something that we also discussed in the MCO webinar, the last one. Also, we have the device name. Also, we have involved turrets. Same thing as the involved channels as well. Okay, just in this case, which are the turrets. And then we have sync start to start. Basically, sync start to start is the it will be 1 in the cases of the balanced draft operations. Okay, and then here we have also superimposition axis. This is something that I will talk in most. We have superimposition mode is true or false. We have internal sync label. I will say when it's no and yes very soon. And then we have number of jobs in the label. As you can see in the sync label 10, we have only 1 jobs, or let's say 1 item. In the label 20, we have 2 of them. So what is all about? So let me just jump into channel synchronization. So label 10 have only 1 item. Yes, that's the setup. A label 2 or 20 has 2 jobs here. A label 40, it has 1, and so on and so on. So let's say for 80, it has 2. This is a nice variable because, for instance, if this variable is 0, maybe you don't have to print the label. Pretty nice when you are debugging the post. Okay. Now the superimposition. Let's see. In my label 20, I would have the superimposition. Now, this is very interesting because my set sync label it's 20. My superimposition axis it's x1 and z1, as you can see here in the label, but my superimposition mode is false. Okay, so what this means? So we are just indicating that in this label, superimposition axis is there are some jobs that have the superimposition axis, but it's still not on. Okay, because you can have more jobs over here, and only few of them will have it. Okay, in this case, internal sync label will be defined. As you can see here, we have 20, and even though the index is 10, we don't have 30, but we have actually 40. Because of that, let me just go here. Because of that, internal sync label here it's no, but in the next one here we have internal sync label, which is set to yes. We don't see them in the interface, but it is necessary to say, okay, we are now running superimposition mode. So we need to know exactly when the superimposition mode is active, and this is very, very important for it. Okay. Basically, as you can see, this procedure is nothing so complicated, but it is crucial to define the sync label. Okay. Let me talk about sync labels and how to define them inside the post at the end of this webinar, because I do have as a bonus content to show you one of the applications that I think that are the let's say it's absolutely free, and I will share with you. You will find it also in the description of the video, and you can download them. And basically, it helps you to read the code and the labels itself. Okay. Okay. So this was about the sync process. And the last subject for today is the output, Gcode output. Here, probably many of you actually asked me, maybe you remember this, you know, of what is the output Gcode for the channels, what should I use? And SolarCam actually offers 3 different options. It's mixed on single file, separated files, or on single file. Now, first of all, let me explain you that this parameter will be only available if you have channels. If you don't have any channels here, if you don't have more than 1 channel, this parameter will not be there. Okay, so this is the first thing. The second thing is that we create this parameter of because of the different controllers, okay, to support different controllers. Now, it's not the primary, how should I say, a reason which we actually define this is because of the controllers. Actually not, but it's because of the Gcode output style, okay. For example, mix it on single file. Probably if some of you are familiar with the Kuma machines, I will definitely use the mix it on single file because this is how actually a Kuma works. Separated files is something for the Fanuc style guys. Probably you know that you need to have somehow the two files, and each channel will have separated file. Now, order on single file, it's something more for the Mitsubishi controllers, where basically you have everything on the single channel. Everything on the first channel it's on the up. Everything on for the second channel it's actually down. Okay, so I would like to summarize when you should actually use these actually options. In this post, I actually use the order on a single file, and I think this is maybe the best one to start. But before actually I will start from the mix it on a single file. I think it will be easier for me to start with this one. But basically, before I start with explanation on this, I'll just go to the channel synchronization and explain you the flow of the information. The flow of the information is the key in understanding of how to write the multi-channel machines. So, as you know, let's forget about channel synchronization for a moment. Let's imagine that this is simple 3-axis machine. So the flow of the information, it always goes from top to the bottom, from the start of file to the end of the file, and everything what is saved in the start of file basically will be the same at the end of file, and the information goes from top to the bottom, basically following the CAM tree order. So we go from one job, start of job, end of job, we have MCO, then again start of job, end of job, up until the end when we have end program and end of file. So probably all of you are familiar with this. Okay, that's nice and it works very well up until you go to the multi-channel. Okay, in the multi-channel, SolidCam works and share the information exactly the same. Okay, so you need to understand that flow of the information will also follow the CAM tree order, but with some small modifications when you're turning on the channel synchronization that you need to understand as well. So I will now delete all, as I did that earlier, and I will just go in 1, 2, 3. If I do it something like this, basically the flow of the information will be like this. So each label will be like a separate file. Okay, so you can imagine that first we will have the initialization post, and we'll have start of file, and then everything on the first channel will be generated first. Once we appear to the second label, the Gcode generation will stop, and we will go to the second label where we'll read all the jobs there. Okay. In this case, we don't have any jobs, so only the sync process for this label will be generated for channel 2, and then we'll just jump again to the channel 1 and then sync label 20. In this case, we don't have any labels here. Sorry, we don't have any jobs here. So we'll stop over here, and the information will go again to the second channel, and then again reading from top to the bottom. So this is clear, I guess. I'll just go to the Gcode in this case, and I will just go to the trace 1 and to demonstrate you this. Okay, so we have the start of file. We'll have the very first sync process. We have also the start period. So we have the first sync process. We have the sync label 10. We have the setup. Okay, and then as you can see, we have the jobs that are related to this sync label. And then we have another sync process, again the sync label 10, and then it will be the channel 2. As we don't have any jobs here, as you can see here, we are going to the next sync process. Basically, this is the workflow of and flow of the information or the mix it on the single file. Okay. Now, This is so nice, and I will recommend doing this, using this for most of standard military machines, also Fanuc-based and like a Mazak. Also, it can be done also in a Kuma. On most of those machines, actually, you can use the mix it on single file. In general, on every of the machines, you can use any of those three. There's no limits. There's only about would you use, the open close structure or not. Okay. Now I will go to another example. Okay, so now we have here the sync process, then we have the end program, and then we have one end of file. So this is very important to say that we have only one end of file. Okay, now let me just do the following. So I will just now load the superimposition one. And now I'll again generate the Gcode with trace one. Okay. So in this case, we have a little bit different because here we use the splitting option. Basically what it will be is that everything starts from this label, then we will have this job. Here we have another label, so we'll come back to here. Then we will load this one. So basically we are not destroying the country order. So the country order, it's follows, okay? Now there is one thing that you should know. If you have the third channel here, as you see, and also or maybe fourth channel, doesn't matter. You need to understand that the flow will not, it doesn't have to be always channel 1, 2, 3, 4, and n channel, okay? The order of generating channel are not always, the same. It depends on the country order. So if you have here this job, then you don't have any job on the second channel, but you have on the third one. Basically, the second channel will be, in that case, will be ignored. It will go first the third channel and then the second channel. Okay, so the country order, it's always respected, and this is, once you understand this, the flow on the information will be much understandable for you. Okay, so back to the analyzing the Gcode. Sorry, the trace. So we have here, I will just go on the top. We have the sync process one, nothing there. Then we have sync label 20, and basically we will have the job itself. We will have the internal label for the superimposition, also for the second channel, and then we'll go to the label 40. Sorry, go back to the label 20 still here, and we will have the job here that for this operation. Okay, so again, nothing different from what I told you earlier. Just you need to understand that now the channel synchronization comes here. We'll split the code according to the labels itself. So still following the order in the country. Okay, now let's go back to the working style, and let me explain you the main difference if you use now order on single file. I didn't forget the separated files, but separated files basically come up from the order on single file. The order on the single file basically is very similar to the mixed one, but now the flow of information again is the same, except that the output in the trace will come everything for the first channel and then the second channel. Okay, so let me go here, 7 exit. I didn't change anything inside the GPP. I'll just generate the Gcode and go to the trace 1. Okay, so here, what's the difference? First of all, we have the start of file. We have only one start of file. We have the start of program. This start of program, in this case, it's very, very important. As you can see here in the start of program, we have now a thing labeled 10, 20, but even better, you can see that channel is always 1. Okay, now channel 1, always channel 1. So first, everything will be done for channel 1. Okay, but this is only inside the trace. The flow of information is still the same as I explained earlier. To prove you that, I will show you actually a very nice example. I will go here. We have the sync label 50. we have the sync process, rapid lines and stuff. Let me see where we are. And then we have, where is the end of program? Here it is. This is the end of program. So everything between the start program and the end of program is basically first channel. Okay, as you can see here, it's the first channel. Here is the last sync. And then we have actually, again, the start of program. Okay, the start of program here starts actually basically the second channel. Now, coming back to the flow of the information, let me do one example here. Okay, so what I'm going to do here is the following. So let me analyze the information flowed in the following label. So let's say that would be, let's say the label 40 is perfect. So we will change the value of particular variable, and we will analyze it in both channels, regardless to the Gcode output that actually we used in the SolidCam. So let me give you one very simple example here. So here, if sync label equal 40, and if channel ID equal 1, then I would like my, let's say I'll call it test here, and I'll just type some value here. And else I would like my test to be 0. And if basically like this, yeah, I need to print it out. So I will just say here test value, and then I'll print the test, and I'll have to declare this as a global integer, and then I'll just call it iTest. Okay, so let's go to the output trace. Let's do the 1. Okay. So, okay, so the flow of information, how it goes. So we have the sync label 10, then we have 20, then we do have 30, which is the internal sync label, then we have 40. In the 40, it is obvious that our test value is 44, in previous was 0. Now remember, the flow of information. Now the next one, according to our if statement that we just wrote, because the sync label is not anymore 40, it's now like 50 and so on, we'll basically get this value as 0. Okay, if we analyze furthermore the trace, we can see if we go from top to the bottom, and after this, once we reach the end of the program, we still see the test value is 0. So let's see that this is the next start of program over here. And we have, again, it's 0, it's 0, it's sync label 30, it's 0, but my sync label 40, it's 44. So even though that I reset it at the top, you need to understand the flow of information. So the flow of information always goes like channel 1, channel 2, then label this, then operation, then go to the label next, and so on and so on. Yeah. So pay attention when you are making some user-defined variables about this. Yes. So the difference between separated order and single file and separated files is that SolidCam will automatically cut this Gcode into one file, physical file. As you can see, this is everything in one file. And from here, from top to the bottom, it will be another file. Let me just go there. Let me select separated files, save and exit, and generate the Gcode. Exactly. So as you can see here, we do have basically two files. And let me just go to the trace 1. It will be even easier for me to get this. Yes. Okay. So we have the one startup file here, but pay attention that you have another startup file here. So this is very important, because if you analyze the first two codes, basically here we only have one startup file. Okay. Also, we do have like two startup programs. Okay. But they are completely two separated files, as you can see here, from start program up to the end of program, and basically end of file. Also, the difference between the mixed on single file and order in single file is that you will also have, in that case, only one end of file. So my suggestion to you is never assign the values in the initialization post, basically start of file and also the start of program. Basically, it means if you want to assign some values like this, never go, with start of program, okay? Because the start of program will, in some of the cases, will come once or twice. So you need to be very, very sure, what you're doing. I will always recommend to never assign the values in start of program, but actually to do that later if you want to support actually the output that you wish. Also, coming back to the question, which one actually I should use? Basically depends of the Gcode style that your particular machine requires. Okay, so that's not explicitly means that okay, for the FANUC we will use separated files. For the Mitsubishi we will use order in single file. For the Okuma we will use mixed and single file. So this doesn't actually mean exactly it's not, this is not the rules. The rule means like basically the minimum necessary to use the open and close structure in order to generate proper code. Okay. And for the end, I would like to show you how to insert the sync label, basically how to generate this. In this case, it will be the Mitsubishi. And as a bonus sync process here, I would like to implement the wait mark, guys. And this is pretty easy on the how it's called on this machine. Let me just move it how it was. On this machine, I'll just use, it's basically, this is how to decide the label. And here it goes with the label 10 or label 1 and so on. And this is the way how actually two channels communicate between each other. And in this case, what I'm going to do, I will just, type this and it will be basically sync label. So as it is, very simple, guys, okay? So this implementation of sync process, it's mostly it's done everything by the channel synchronization, and just the sync process is the procedure actually that will be used, and the sync label basically will give you proper information as it is. Now, reading two files or one file, you need to have a proper Gcode viewer, let's say like this, or Gcode editor, okay? In this case, at the end of this webinar, I would like to give you completely free software that you will be able to download it in the link description below. You will also see it later on the website. And basically, it allows you to see the codes that are completely separated and also divided by the labels, okay? Now, probably you've seen during my webinar that I actually use the Simco in most of the cases, okay? And in this case, I would like to give you this completely free software that was built by Solicam UK. And I'll just go to the Solicam settings. And here in the Gcode, for the editor, I'll just use this application. It is called the SyncMaster. And it's very important that you check on this multi-document editor. So if you have more than one files in the output, I recommend you to use this checkbox. Basically, it will open both files into the same window, let's say like this, okay? So I'll click OK here. I'll do a right click, generate Gcode. Okay, so as you can see, this is the application. Basically, it allows us to see these labels per each channel, okay? And I will just very quickly, go through this application so you also understand how actually you can use it. By default, I will just reset this. Here you have a settings, and this is the Gcode actually that you got, okay? Now, by default, you will not have any any machine, and then you can basically create a new one. Okay, so you can create your own if you wish, or you can just rename the one that you have. And it goes through very simple wizard about the structure of the program. Is it the one file or is it a separate several files? So the several files will be most likely, you know, the old Fanuc based controllers, and one file will be, except, for example, the one that we have here. Also the Akuma one have also the one file. And here you see everything like in the one file as I showed you earlier. Now here the channel symbol. So basically we need to put this symbol for the channel. And what is in these brackets? It's the C, represent the C. The C means, you know, the channel number, okay? Now there is how many active channels can be, 2 or 3. Now the application is limited to the 2 or 3 channels, and over here we have the example actually what is the channel, how the channel actually is distinguished. And then here we have recurring commands, or let's say wait commands. It's like I just already defined, just simply type this, and in the parentheses you put the queue, where the queue can be from, I just defined from 1 to 200, but basically this is defined by the controller itself. So basically here is the example of how it will be. Now here we can now divide. This divide button, before I go to the divide button, I will just, you can also export these settings, so you can actually use it later. And you can also import it here. It's very nice. Now we can also make a divide button here for the single file. Divide button is very important, so you can divide. Nothing, it's still synchronized. Okay, so you can just see it by the channels, and then we can actually synchronize. Once you synchronize actually the code, you can actually see it as per a channel synchronization that is actually defined in SolidCAM. Okay, I hope you like this webinar. I hope this was enough input. If you have any questions, I'll actually go through the okay, so we have 2 questions. So the first one, is there a list about the normal default and the other option that does they mean and how it works in Solid? Okay, a list about the normal. I'm not sure what you mean about the list of the normal. And basically, okay, the question is, I'll try to replicate. Is there a list of what each of these actually can be and how it behaves? Basically, I will say like this: forbidden, it basically I don't allow you to use it in that particular channel. Normal means yes, you can use it, but it's not as a default, which means if I go to the channel synchronization, this first label, as you can see guys here, this means it's a default. It's very first label and it's a default. Now, as you remember, for my Y1 axis, I said that it can be used on the second channel as well, right? But it's not there as a default. So this is the same. This is probably the answer to you. Also, the superimposition and superimposition, the default, the same thing. Okay, so you want to use it only this axis only as a superimposition, yeah. But in this example that I show you guys, I must use superimposition and normal. It's basically the combination of superimposition and those what I already explained. As you can see, I in this case I must use it because I have some job over here that I use for the main spindle. Sorry, I will rotate the part like this. So I will use it over here in order to have a superimposition, yes. Otherwise, I cannot use it, yes. So for each machine, it may be different, yes. Hopefully, this is more information about this. Another question is how I make the simulation so smooth. Okay, let me just jump to the simulation itself. This is off topic for the post-processors, but I think it's also maybe it could be viable for everybody who is actually analyzing the machine simulation. In machine simulation, I'm not sure how well you will be able to see it as it is going through the TeamViewer, but you have 3 different types of the simulation. If you go to the simulation over here, here you have the simulation, okay? And here you have the mode. If you go to the NC mode, basically what you will be able to see is just lines, straight lines from each of the block. And that's why you actually can see sometimes the simulation is pretty choppy. So probably, Mikhail, this is the reason why you actually see this simulation. So if I run it right now, you will see that it's very, very choppy because it runs each code with a very straight, sharp lines, yes? But if you go to simulation, let me just reset the simulation. And if I go to the time mode, if you put everything in the middle, it means as I program, the feeds and speed will be taken into account, okay? Which means if I put it in the middle, as you can see here, it will be exactly the same on the machine, okay? So if I run it, this is how it is on the machine. Probably you mean about this. And another mode, it's the length mode. It's something between the time mode, except that the factor it's not a time, but it's the length of the toolpath. Okay, so you can run it and it goes a bit faster. Okay, and this parameter cannot be changed. You can just maybe put it to be slower. Let me just know and reset, and I will just hit play. Yeah, so this is probably what you mean. Let me go. There's more questions. Seems to be. No, there is no more questions. Okay, so thank you guys for attending this webinar. I hope you enjoyed. This will be probably the final one. We'll see if you will have any more requests. Please come back to me, and we'll consider about the next webinar. So I wish you very nice pleasant of the day, and talk to you soon. Bye bye.